Hi everyone, thank you all for joining. I'm looking forward to show you all the new features we have embedded in the new release in December, or as Brian said, as of tomorrow. Not a few months ago, in September, I had the pleasure to show you all the things in there, and in the upcoming months we have added tremendous new nice features for you as well. So I'm really glad that I can show you this already. So let's dive into it. With each release, we aim to contribute to a Medis Suite MR, which is quick and easy for your clinical daily routine. And we're doing that based on 3 target pillars: the efficiency, the quality, and the robustness of the platform. And in this release, we have done that for the following parts. We have embedded a T1 motion correction algorithm, so you don't need to do less editing for the contouring in there. Contour algorithm within the function analysis. We have cleared our strain application, so it can be used now in your clinical routine and not only for research anymore. Then what else has been done is the enhanced vectors in the 4D flow application. So the vector visualization has been improved, so they are now following the streamlines for a better direction of the flow, or to show better direction of the flow. And at last, for our robust platform, last time we had introduced the role-based access control, and now we have advanced this with the capability of also providing different users access to the repositories. So we'll go over all of these in a bit more detail, and then at the end I will also show you these things live in the application. So to start with the T1 motion correction, as you can see in the image, at the left-hand side, you see the T1 images without the motion correction, and at the right side, you'll see them with the motion correction. One is pre-contrast and the other is post-contrast. So we have embedded the correction algorithm at one of the AutoCue files. So besides the contour detection, you also now have there the capability of choosing for the motion correction algorithm. The aim is, of course, that it saves you time. By aligning all these images, you only need to draw the contour once and don't need to adjust them over the other time points, which will save you editing and therefore directly the results of your T1. This can be applied, or this new series that are being created after this algorithm, can be applied in both our QMAS as in our QMAP application. So it's validated and therefore can be used both in clinical and research parts. Then to the next one. Another one for efficiency. The deep learning has been embedded in the function analysis. So let's show you how that looks like. So previously, you needed to create an AutoCue file up front. This is still possible, but if the data just comes in, it will need some time to get this whole file. And now it's embedded within the Auto button. And by clicking on that, it will automatically detect it for this phase. And as you can see, it only takes a few seconds for it to get the results for each of these phases. If you delete it for, I don't know, it will be saved and stored, so you can then quickly, if you run the Auto button again, it will be there just within a second. So this is capable for all of the deep learning detections. So we have currently 2 modules embedded, and you can choose the one you want to have embedded in there. So previously we had updated our algorithm in there, and we have got excellent feedback on that. That you only need to modify it in a few slices or only in a few cases. Also, we have got nice results for pediatric cases, although it's not necessarily trained on that, it's working very well on those. So with this now embedded as well, even more optimized the analysis and the workflow for you in here. So I don't see any questions so far, so let's continue to the next one.
There was one question, Kayleigh, coming in, whether or not it works on cardiac motion as well. The motion correction.
So thanks for asking. So the motion correction is designed more for breathing motion, but it will align it all based on the different slices. So also if you have, for example, the pre and post contrast images, you can select them together and then they will also be aligned on top of them. So there will be a bit of non-rigid registration. However, it's cardiac motion is a bit more difficult to correct for than only for the breathing motion. I see another question coming in regarding the RV apicardial boundary. So currently we only have the LV endo and AP and the RV endocardial contours. We don't have an algorithm as of yet for the apicardial boundaries. Thanks for the questions. Then the next part is that our strain application has been cleared. I will show you here how it's currently looking. So with the results we get from our deep learning contouring algorithm, we can forward it to our strain application. Select there the different slices, in this case the short axis, but the same will account for the long axis of the left ventricle, but also for the right ventricle and for the atria. So all the 4 different modules are cleared for clinical usage. So after it has been tracking the contours over time, you will get the results accordingly. Since it's a short axis, you will get there the global circumferential and global radial strain results. And as you can see, all of them are now embedded in the report, so they can also be used for your clinical routine. Also, snapshots and movies can be saved and can be stored in here as well. So the strain application is now cleared in the United States, in Europe, in Canada, in Australia, and in Japan. So there you can use it within your clinical routine. So we see as well that the strain values are being used more and more for clinical practice. So with this, I think it's a really nice tool that you can use to get those values directly in. So the output we see in the report, I see a question whether the strain is cleared for both segmental and for global values. So the global values have been truly validated and therefore also visible in the report. The global or the segmental values are based on the same algorithm. However, they are not shown in the report as a different 17 segment module, but by creating the snapshot, you can get those results in. Hope that answered that question. And otherwise, during the live demonstration, plenty of time to follow up on that. So, then another enhancement that we did regarding the quantitative part is the factors of the 4D flow. We have enhanced them since previously those arrows were static. This can still be set. However, now it's nicely following the streamlines, so you can see really the direction of the flow and also where they are going, and we can change the settings. So we can change the number and size of the arrows, so to make it really specific for the area you are looking in. So this will help you to provide the direction and have a better indication of how the flow is going, if there are any leakages or if there are any shunts available. So actually it's quite unique. We are the only software company that's providing the vectors which following the streamlines. So we hope that you like it as well. The first feedback is very positive regarding that. I see two questions, so let's first answer the 4D Flow one and then go back to the other one. So in 4D Flow, can you export movies of the streamlines vectors as secondary captures? So currently, we don't have the ability of exporting movies within the application. Of course, other recording tools can be used to create movies regarding. Snapshots can be taken from both vectors and streamlines, and those can also be saved as a DICOM secondary capture. Before we go to the other question, let's continue with the 4D Flow. So the question is, how can we select those streamlines with the 4D Flow images? I will show you in the live demonstration. Let me write it down. Oh, I will show you anyway. I know that for sure. And then the question, I think it's regarding the strain application. How does it select the short axis levels, the mid, base, and the apex one, or the base, mid, apex one? So the application is not doing that automatically. You can yourself define the base, mid, and apical area. And for the long axis, it will define it itself by part of the 16 separate segmented module. Okay, so then the part regarding the platform. So we have last time embedded a role-based access control. This means that you can define which of the users is allowed to do what with the application. So for example, it can be that some persons are not allowed to anonymize cases and others are not allowed to edit any cases. But also for data protection, it can be that some are only allowed to see the anonymized cases or the anonymized repository and are not allowed to see the clinical data. Or maybe you have a shift within your department that some are looking at certain cases than others. To make sure that you only see the data you are either interested in or allowed to see, this can now be set within our settings. So this way we can fulfill your security rules, since it can be that there are specific requests for each hospital. Here in the image, you can see that in this case, the standard operator has access to both the different repositories, but you can manually check or uncheck different repositories in there. So it can be made user specific or user groups specific. Those are the major enhancements that have been made in this release. And on a more general basis, we have also had some additional enhancements. One is regarding the installer. It has been simplified. So previously you needed to install each application separately, and we have combined it. So you only need to run one installer. which makes it easier for your IT department or for yourself. And secondly, there are also cache improvements. So it's now easier to see the amount of the cache or where it's located, when it will be cleaned, and you can also clean it yourself manually. Those are the things I wanted to discuss with you before we go to the live demonstration. I don't see that there are any open questions for now, so let's continue to that one. So we'll keep the order as in the presentation and therefore start with the T1 motion correction. So here in this data set, you see different MOLI sequences. And for example, here this one is an image of the pre-T1 port. And here with the right mouse button, we can go to the auto cue options and select here the T1 motion correction. As you see, likewise with the other auto cue modules, you will see here the working guy in the status bar appearing to give you an indication that there has been algorithms going on. And also in the auto cue status bar, you will see which algorithm or which series is currently running. So you see that I started it, and you can also see that it's currently already done. So if we go to the browser, you will see that a new image has been created or a new series has been created. You see that I did this already a couple of times. They're all named the same. So in comparison to the original data set, you see that now the words MOCO have appeared behind, standing for motion correction, and also the series number is appeared behind. So if we now load this data set, I can show you in the viewer the original one. And the one we just created. Let's turn the speed a bit down so you can have an indication of how it's different from each other. As said, we can load this both in the QMAS as in the QMAP application. So here in the QMAS application, I can draw a region of interest and then go to the T1 analysis tab. We see that there's 1 point still misalignment. After having that one deselected, you see the nice curve going in here and the results accordingly. The same applies for the QMAP application. So in the QMAP, you have a bit more options on how to generate your data. Next to the region of interest that you can draw, you can also create bullseye plots, for example, if you have multiple slices, like in this case. But also region of interest in here is possible. So now based on this region of interest, you can see the number in here as well. You can also see the curve accordingly to see how well the dots are fitting. So this is when you have just one T1 series you want to correct for motion. If you have multiple series, like a pre and post-contrast image, you can also select the both of them. So here we have a native and we have a post series. if we select both of them simultaneously, and then we can select the auto cue option and the T1 motion correction, then it will apply the motion correction on each of those, but it will also align them on top of each other. So it can also be used for ECV measurements, for example. So I think that might already answer the question. If under the QMAP T1, we also allow to do calculations of the ECV. So the ECV, it works a bit the other way around actually. The calculations of ECV provide you also the values for the T1. So with this algorithm, you will get two new series. As you can see in here, you will see not only the series of the pre, but also the name of the series of the post where it has been aligned with. So since it has a bit more correction to do, it takes a bit longer, but you see there are the results are already in. So I can show you also how this works then for the ECV. So this is an analysis done before, but let me show you from the start. Get those in as well. So we have here our pre and our post contrast image. We can draw a blood pool and we can fill it in with a grid value. So based on that, you will get your ECV map. If I draw here a region of interest, then it will also copy it to the other areas, and you will get the results both of ECV, the T1 native and the T1 post area. I see another question regarding the T1. What kind of correction factor should be applied to Siemens T1, Tesla and 3 Tesla? Is it the same or is it different? This is a bit depending on the settings of your Siemens scanner. There are different approaches that they are applying, and based on that we have also different correction factors. So this is something that well, needs a more personal answer than a more general one. So please, I will provide us with your, no, I think we have your email address. Now we can have a closer look to your settings. Okay, thank you all for the questions regarding the motion correction. Let's close this and let's continue to the contour detection within the function analysis. So here in this case, I already have the AutoQ file, so I could use those of course as well. But in this case, I want to show you what are the options if you don't have the AutoQ file yet generated. So I can load in the short axis, but also the long axis into the function analysis application. So you can see the lines in here as well, and to give a bit of direction in the 2-chamber and 4-chamber view. And you see that since there's no AutoQ file available, the grid will still be empty. So we can scroll through to find the end diastolic and the end systolic phase. And then we can press on the auto button. By default, it will also create the LV endo and epicardial contours. We can also select the right ventricle endocardial contours and then press the detect contours. Here at the bottom, you will see the time lapse for the generation of the contours of the algorithm. And likewise, we can go to the systolic phase and generate there those contours as well. So as you can see, it only takes a couple of seconds. And of course, we can evaluate the contours and adjust accordingly if necessary. So for example, we can move those. And the same for the diastolic phase. So we can use either these contours I wanted to continue actually with the strain application, but just realized that there might be questions regarding this part. I don't see any open questions, so let's continue then with the strain, and if there are any questions, just write them down and then we'll go back to that. So these contours can be used for a strain application. Since in the presentation I showed you already the long of the short axis, let's draw some contours in the long axis and do the strain on that. I do see a question in the meantime, if it will work with the mass K. So the mass K will be working, but only for the left ventricle part, since we didn't draw the epicardial contours of the right ventricle. So let's continue with the contouring at the 2 and 3 chamber, or the 2 and 4 chamber. We'll use here the BBA marker to select twice the base and then the apex. Can still do some rubber banding. And we'll do the same for the 2 chamber view. And now we can go directly to the strain application, and then those contours can be reused. So of course we can also select the contours from the short axis, but in this case I will show you for the long axis. So select the 2 chamber view and the 4 chamber view, and then go to the next step. If you have used the strain application before, you might notice that the background color is now not purple anymore, but gray. This is to indicate that it's now a clinical application. So nothing has been changed on the algorithms, so they are still the same as previously. So the results will remain the same as well. You can also still go to the time to peak analysis, for example. And if you want, you can also take a snapshot of this. Also, a movie can be saved here of your image, so based on the tracking. And the main difference that you will see is that now also the report has the strain values embedded. So next to the volumetry measurements, you will see now also the strain part. So you can see that this is now based on the long axis, the different values. You will see here also the snapshot that we took, and you will see also an image of the movie. So in this case, since the movie on a paper is not that interesting, we can also, of course, remove it. So the movie can be exported to any location here on your computer, either in IV file or how you would prefer it. And then you can use it in a presentation or to show to your colleagues, or how you foresee that. I got a question if I ever adjust the non-ED and ES contours. Do you mean in the strain application or for the function analysis? So for the strain application, we only have the ability to, for strain, okay, thanks. Only have the ability to change them for ED and ES. So if I click here on the ES part, I can do the changes accordingly. I can view the different parts. But that basically means that I'm also changing my ES space. So here you see now that I'm at the ED, and I can also go to other faces, but by adjusting them there, I actually am adjusting the ED face. So if I would do the adjustments here, I will make this face the ED face. Of course, this can be needed, but be aware of that. And then another question. Can we do the strain analysis on the 4th chamber? Horizontal, long axis. Please show an example. I'm not sure if you mean any other plane than this 4th chamber that is embedded in here as well. We can switch here between the different series that we had selected. So we had selected both the 2 chamber and the 4 chamber. So just the first one appears in the screen regarding the contouring. Also, the 4th chamber is available to see and to check if the contour tracing is done correctly. I hope that's the answer on your question. Well, thank you all for the questions also regarding this topic. It makes it interesting for each and every one of us joining here today. Let's go to the last part that has been enhanced for the MR part, and that's in the for the flow application. I see there is another question regarding strain. I'm sorry, I just closed it, but yes, you can exclude a specific segment for the global calculation. If you click on one of the segments, it will be excluded. So in the bullseye, all the colors that are there, if you click on it, it will be excluded. You don't see the numbers there anymore. So meanwhile, loading the 40 flow case. So as you can see, always a lot of data in there. So there it is already. So we'll load the 40 flow series, but I will also load some 2D CNET series within the 40 flow application. So once the data is loaded, I will first remove the noise, and I will do a background subtraction to correct for the offset. In this case, I know that there's no aliasing artifacts, but if so, I could just apply this button and then I can correct for the aliasing part. I do want to show you here the difference in visualization for the different areas. So let's see. So here, visually, we now only see the speed, and based on the color coding in here. Here at the top of the 3D part, we can change here from speed to either streamlines or vectors. So I think that was one of the questions I promised to do during the live demonstration. So here you see now the streamlines. So you see the way that the flow is going, but you don't necessarily see the direction, although you might have, of course, indication based on the vessel. Now, in addition, the vectors are moving along those streamlines. So here you can see that, let's zoom in even a bit more to have a clearer indication. Also highlight one of them. You can see the different arrows, and you see that also the larger the velocity, or the higher the velocity, the larger the arrows. And we can play around a bit with the size of the number. So the settings have now been moved here to the top, so I can change, for example, the size. Maybe I think as them too small, so I can say instead of 100%, 120%. Apologies. And maybe I think actually that there are currently a bit too much arrows, so I can also change the number and change them, for example, to 80%. So the density of the arrows has now been lowered. So you can see the direction now of the blood flow, and you can see that the arrows are not static, but that they are moving along the streamlines. So this is all within the 4D flow data set. You can, of course, hover to the location that you want to indicate any areas. But I do want to show you as well that in the 2D images, your regular scene images, this can also be applied. So also here you see the different arrows. Need to zoom in a bit to get a bit clearer indication in here. So here as well, we can see that, for example, in the pulmonary artery, the flow goes twice, back and forth, and now in the aortic area only once. I see there's a question. If I have an example of a septal defect, unfortunately not. If you do have one, let me know, and I'm curious to have a look at it and maybe to incorporate it in our demonstration data sets for the next time. So those were the major things I wanted to show you for the MR part, what has been changed in there. On a platform basis, I do wanted to show you the additional things as well, but therefore I will go back to the browser. So these are general, also applicable for other product areas for XA or for CT. So when going to the settings, I can show you there the different items that have been added. So one is regarding the users and roles, and regarding the differences in the repository access. So in this case, I have two shared repositories, one for my 40 flow data and one for my demonstration data. And I can give access to each role. So for example, the standard operator has not only access to the demonstration data, but the administrator can still access both. Or maybe I say you are only allowed to see the 40 flow data. I see that this can be very useful for research and clinical usage at the same time. So both research department and clinical department are using it. And then it's important, of course, that the research area only sees the data sets which are anonymized and in a specific repository. But I think it will apply on more areas than just this one. Then the other part, which I told you about regarding the cache, this is also here in the settings at the repository part. You can see directly the location of your cache, the size. You can also clear it there with a one button press or move it to a different location where there's more space. And by default, it will be, the time will be set when maintenance will be occurring. And with that, I mean that it will automatically clean up the cache and remove the items that are no longer necessary. So you can set this at any time. 2 o'clock is usually a time that nobody is at the hospital or research center anymore, but you never know how enthusiastic you guys are. So maybe another time is more appropriate in your case. And another one, a part that has been applied for the cache part is that with the eye here at the top, now you can see the current applied repository storage and what is still free. So with that, you also have an indication on how much data is in there and how much data you can still import. So at the moment, when you start importing data, or whether it's now pushed from the scanner, we will check the amount of data at the size. If there's still enough space, if there isn't any space anymore, then we'll give a warning as well. So you are aware that there is an issue on the data side that causes it not to appear in your repository. Oh, as you can see, I already have it installed, but I hope that the screenshot showed you how simplified the installer has become. I see no other questions, so hopefully I've answered all of your questions. If not, you can always send us an email, of course. Also, if you want to know how to install it, how to get this version, etc., we are pleased to help you out in that. For our customers under the maintenance contract, they will get it as of tomorrow.